Okay, let's continue. We're going to talk about identity metrics. So, I've told you, right? Each matrix got like a letter given to it or name, and all identity metrics are called I. So, yeah, basically that's all. And the unique thing about identity matrix is you multiply with anything, right? Like you multiply with A or you multiply with B, you will get the same value like A and B. So it's kind of like identity matrix is kind of like one, not exactly one, but it's kind of like a one because you multiply with I, you will get the same thing. And you need to make sure that if I take I and multiply with A, it must be equals if I take A and multiply with I. So even though the order changes, the value should be, oh, sorry, it's actually IB. Even though the order changes, the value should be same. If that's the case, then these I are called identity matrix. If not, then they are not identity matrix. So identity matrices, they kind of look like this. So first of all, they always will be square. So they can be 2 by 2 or can be 3 by 3 or 4 by 4, but it's always square. Second thing, they start from 1 and then diagonally there'll be 1. So let's say it's 2 by 2 identity matrix, right? So two rows and two columns, it will be like 1 1 0 0. So diagonally it will be 1, and for 3 by 3 it will look 1 1 1. So 0 here, 0, and like this. And 4 by 4 it's kind of look like 1 0 0 0 0 1 0 0 0 0 1 0 and 0 0 0 1. So it's kind of like predetermine, how the identity matrix will look like. And if you multiply these, uh, not not mattering the order, if I multiply the matrix here or matrix here, I must get the same matrix. If I did, then this is called identity matrix. Okay, let's look at some questions or some examples. So these are the one I already showed you. And which are the following matrices, identity matrices? Well, this is not, obviously, because this is not a square. This is a square, but 1 should be here and this should be 0. So this is not 2. This is definitely not, because this should be 0 0, a lot of errors. Okay, this is identity matrix and this is identity matrix, because two things, right? But both of them are square and then diagonally they are 1. Here, even though they're square, the number should be like 1 1, so it's not diagonally 1, so it's not the identity matrix 2. Okay, it's given that C is this and matrix D is this. Show that matrix D is an identity matrix. So what you're going to do, if you need to take C and then you need to multiply with D, now you need to get C. And it doesn't stop there. You need to take D and then multiply with C, and then you need to get C2. If you do this, then you can show that D is an identity matrix, and that's how you get marks for this question. And now it's given that S is this and matrix T is this. Calculate Si plus Ti. So if I times S with I, I'll get S only, and if I multiply T with I, I'll get T only. Here S, you multiply with I'll get S only, and then I multiply with T. Here the same thing for by the way, okay, let me write it here. I T, right? So I multiply. how you're going to multiply doesn't matter. So if I take 4 and times with I, you're not really going to uh, cut anything. So, but if I take I and multiply with t, I can cut that because I multiply with t, I know it's t only. So now 4 times t, and here is I times I, right? So I times I. So what do you think we'll get? Well, if I take anything and times with I need to get the same value. So it's just I. And since it's a subtraction, right? So you need to know the how the I here will look like. Well, here is t. Here, this thing is for t. So t is 2 by 2. So this I is 2 by 2 also. So it will be 1100. And then you take this and then you minus with this. And here, you whatever matrix you get here and you multiply with I, you must get the same matrix, right? So you can just straight away cut that I away. It doesn't matter. And then just now take S and you minus with I. And I in this case is 2 by 2 also because S is 2 by 2. Okay, now what's the meaning of inverse matrix? Okay, inverse matrix is usually denoted as the power -1 of a matrix. So the inverse matrix of A is A power of -1. And so what does this inverse matrix does? Basically, if you take the matrix and then you multiply with the inverse matrix, you need to get an identity matrix. If you change the order and you do a multiplication like this, you'll still get I. If you do that, that means this is an inverse matrix. So now determine whether the following matrix is inverse matrix of this. So let's say this is A and this is B and maybe this is C. So the first question, A, I need to take A and then I will need to multiply with B, and now I need to get 1100 because this is 2 by 2 and 2 by 2, and the result should be a 2 by 2 also. Now if I take B and A, I need to get the same thing, 1100, and in this case they didn't, they got a completely different answer. So that means this is not the inverse matrix. Here you multiply here and then here, so even though you change the order, you get 1100 and then 1001 here, 1001. So that means this is an inverse matrix, or you can tell this is the inverse matrix of this, and that's what they wrote here. Okay, and that's how you're going to do this question. And now you know how to make sure, or how to determine whether a matrix is an inverse of another matrix. Now how will you find the inverse matrix? Well, you will use this formula. Okay, let's say I took A as 1044. So what I'm going to do is I'm going to change this with this. So now I take 4 and 1 here, and then I'm not going to change these values 4 and 0, but I'm going to change their sign. So 0 doesn't matter whatever sign you put, it's just 0, but here is positive, right? So now you're going to change it to negative. Okay, simple. And then you're going to scale a multiplication with a fraction. So what fraction you're going to use? Well, you're going to take this and multiply with this. So 1 multiply with 4 minus with this and multiplication of this. So 4 times 0. So if I do this, I'll get 1 over 4 minus 0, 4. So 4, 0, negative 4, 1. And if I do this, I'll get 1. 1 over 4 times 4 is just 1. 1 over 4 times 0 is just 0. 1 over 4 times with negative 4, you'll get negative 1. 1 over 4 times 1, you'll get 1 over 4. Or you can also tell 0.25, doesn't matter. So this is the inverse matrix of A, and literally that's all. And this thing, right, only this thing, the denominator is called determinant. Why is it called a determinant? Well, because it determines whether can you find the inverse or not. Why? Well, let's say in here, right, you get 0. If when you do this operation, you got 0. That means it's 1 over 0. Well, can you divide 1 by 0? Well, you cannot. At least in normal maths, you cannot. So that's why if you before you find the inverse, you just do this thing first. AD minus BC, basically times AD minus with times this and this. And if you got 0, it means that matrix doesn't have an inverse matrix. Easy to understand? Okay. So for each of the following matrix, determine whether the inverse matrix exists. If yes, calculate the inverse matrix. So here they did the determinant first, and since they got 0, that means the determinant doesn't exist. So for a B, when they try to do, it's 2, so it's not equal to 0. That means the inverse does exist. So how they did, they just interchange, swap this. So 4 came here, 3 and here, and you just change the sign of this. So negative 5, negative 2. What if it was negative 5? Well, it will become 5 because, as I told, you are changing the sign. And that's all for this. The same goes for this. Actually, let me continue in another video.